Good morning and welcome back to Brodeur Land. It is week 5. That's right, guys. We have hit week 5. And let's talk about what these last 2 weeks, because we got week 5 and week 6. And then you guys start summer vacation starting after May 1st. So what week 5 and week 6 is going to entail is pretty much we are going to wrap up the units that we did not get to wrap up when we were at school. For 8th grade, what that means is we got to finish up systems of equations, which a lot of the classes have already kind of started. We just didn't finish. And then we got to get into our last unit, transformation. So today, what we're going to do is we're going to focus on systems of equations. We're going to focus on the graphing aspect. And pretty much what these videos are really going to be helpful for is because a lot of you guys might not be super confident in this material, or a lot of it might actually be new to you. We're really going to dive in, really make sure I teach you and go over an example and also misconceptions so you can go flawlessly through the example problems you need to complete for a grade. So, like I said, today what we're going to do is graphing system of equations. Let's go over here and let's talk about how we can graph systems of equations. So, first off, like I said, for some of you guys, this may be a review, but for some of you guys, this is completely new to you. So let's start up here. When you do graphing systems of equations, you're going to get one of these types of scenarios when you graph. You're going to pretty much graph 2 lines. Now, what's going to happen is you're going to get either what we call infinite many solutions, no solution, or one solution. Let's start over at one solution because, to be honest, most cases you run into are probably going to be a one solution. And as you can notice here, these 2 lines right here intersect at just one point. That's right, just one point. And if I wanted to be more specific, that point would be what we would call 0, -1. Now 0, -1 would actually be our answer. It would be our solution. And since it only intersects at one point, that's why we have only one solution, because it intersects at one point. Now, let's go to the next one, no solution. Clearly, these are what we call parallel lines. And with parallel lines, we know that they will never intersect. Meaning, if they never intersect, we can never have a solution, which is why we have no solution, no intersection. Next, we have infinite many solutions. Now, you might be thinking, Mr. Brodeur, I see one line. These guys have 2. Well, technically, this has 2 lines right here. And if you look really closely, I tried to put little dots here to kind of represent another line. There are really 2 lines, and they are overlapping. They are exactly in the same place. Well, if these 2 lines are overlapping or in the exact same place, that means they're not just intersecting once. They're intersecting many times, which is why we get infinite many solutions, because they're not just going to intersect one time, they're going to intersect infinite times, many times, more than you can count. So let's go over and we're going to do example 1 right here. This should be your example 1 that you need to complete on today's assignment. And I'm going to really break down what you need to do in order to finish and complete each problem 100%. So first thing is, you're going to get 2 linear equations. 2 equations where you got y equals some number in front of x plus or minus another number. So what you need to do first is you always want to find your slope and your y-intercept for both equations. Now, before we jump into that, the most important thing that we need to remember is rise over run, because that's going to come in handy very shortly. And that goes hand in hand with your slope. So for example, let's go right here. Your slope is always located right there in front of x. And so one thing too, besides rise over run, is we have the equation y equals mx plus b. Okay? If you look at this equation, you would agree that this looks very similar to here. You got your y, you got your 2 and your m, your x, and then your b and your -2. And I'm going to get into this in a second. M, if you remember, or if this is new to you, is what we are going to associate with slope. B right here is what we're going to associate with the y-intercept. Okay? So when I come down here for my slope and my y-intercept, all I'm going to look at is what number is in front of x, or the coefficient of x, and that would be 1/3. So I'm just going to write 1/3 here. That would be what we would call the slope. The y-intercept would be my constant, or the number by itself without x, or to the side of x, and that would be +3. Okay? Now, same thing here. My slope would be the coefficient of x right here, so that would be 2. And then my y-intercept on this one, be careful, it's not just 2, it is actually -2. Oh, but wait a minute, Mr. Brodeur, I just made a Brodeur mistake. When you talk y-intercepts right here, we actually want to put it in a coordinate form. I don't want to just write 3 because 3 could mean anything. It is actually going to be the coordinate 0, 3, because it's where it's going to cross the y-axis. My y-intercept goes where my y would go in my coordinate, and then my x is going to be 0. And that will come, I'll explain that a little bit more once we jump to graphing. So same thing here. When you write your y-intercept, you would set up your coordinate, 0 for your x, and then you just plug -2 or whatever your y-intercept is right there. So you got your coordinates. Now, next thing, let's talk about slopes right here. You got your slope, but you might be going, how in the world am I going to use that in order to graph? Well, that goes back up to rise over run. Rise means the top number of our fraction, and that is going to either go up or it's either going to go down. Run is either going to go left or it's either going to go right. And that's very important to remember. So for example, if I come down to here, that 1 right there is either going to go up or it's going to go down when we start to graph in just a second. So what I do is I try to get some arrows situated and set. So if I come up down here, this is clearly a +1. Does +1, if I start at the origin, if I start at 0, does that look like it's going up or does it look like it's going down? This positive looks like it's going to go more up, so I'm going to go with an up arrow as if it's going to rise up. Now 3 right here, my 3 is going to be my run, and that's either going to go left or right. Clearly a +3 looks more to the right side, so I'm going to put a right arrow right there. And so I'm going to ignore this one for a second. I'm just going to go about graphing this first one right here. So I'm going to go to my graph right here. And what you always do first is you graph your y-intercept. So I start at my origin, and we're going to go to point 0, 3 right there. So I got my y-intercept for my first equation, my first linear equation. And this is why I say write it as a coordinate, because now you see, oh, I got to place it at that coordinate on the y-axis. Now the next thing is trying to create your graph, and that's where the slope comes into play. So I'm going to go to this y-intercept, and it says I'm going to go up 1, because the rise says up 1, and then to the right 1, 2, 3. And you can keep going if you want to. What I tend to do, because this helps me a lot, I tend to place all possible points from my first graph. So that way for the second graph, I just got to play the game of trying to intersect them. So I'm going to keep going. I'm going to go up 1, and then to the right 1, 2, 3. And then clearly if I keep going up 1 to the right 3, I'm off my graph. So I'm just going to stop there. Now before I go on to this next one, I do want to fill out this next side because I don't know which way this graph is going to go. I don't know if it's going to intersect over there or over here. Now this is an easy way to switch your direction and try to plot points this way. First, we went up and then to the right. Now, to go the opposite direction, just go down and to the left. Now, why can I do that? Why? This says positive 1, Mr. Brodeur. You said go up. This is a positive 3. You said go right. Well, technically, I could rewrite this fraction as negative 1 over negative 3. Now, you're like, whoa, hang on a second, Mr. Brodeur. How is that the same? This is a 1 over 3, and this is a negative 1 over negative 3. You're just like changing things on me. Well, remember, if you have a negative on top and a negative on bottom, those get eliminated because that would change to a positive and you get back to your same fraction. So in that case, everything's the same, so it's okay, and that's why you can reverse your sign. So I'm going to go back to my y-intercept. You always go back to your y-intercept. And now I'm going to go down 1 and to the left 1, 2, 3. And then keep going down 1 to the left 1, 2, 3. And then clearly I run out of room. And like I said, I usually plot all possible points for my first graph first. And I'm just going to draw my equation, or my line right there, connect all my dots, and that knocks off that first graph. Now my second graph, I'm going to come over here, and it looks like I got 0, negative 2. And I'm going to find my red pen right here. I'm going to graph this one in red so that way we can clearly see the difference. My issue though is, wait a minute, Mr. Brodeur, this is not a fraction. How do I use rise over run on this one? Well, if you don't remember, I can always make something into a fraction by placing it. I'm going to use the red just to show you. Placing it over 1. Boom, right there. I got it into a fraction form. I'm ready to find my rise over run. Clearly 2, if I have to choose whether it goes up or down, a positive 2 is going to go up. So I'm going to have an up arrow right there. Now 1 has to either go left or right. Since it's a positive 1, that means I'm going to go to the right. So I'm going to go to the right there. All right. Now I'm ready to start graphing. My y-intercept on this one is 0, negative 2. So I'm going to go 0, negative 2. That's my starting point for this graph. And you always do the y-intercept first. Like I said before, start at your y-intercept and then work from there. Now from the y-intercept, it says I'm going to go up 2 to the right 1. And it looks like I'm going in the right direction, that if I keep going up 2 to the right 1, and you want to keep going until you intersect up 2 to the right 1, and boom, right there. These two graphs are going to intersect. Now, I don't need to graph any more points right there. Once I hit that intersection point, I'm done. I don't have to worry about coming this way or all that stuff. That is going to be my solution. So in this case, we actually have a one solution scenario. Now, the final answer is not your graph here. Your final answer is actually the point where it intersects. So my final answer is really going to be 3, 4. So the coordinates 3, 4. And remember, you always go x first and then y. So this would be my final answer. And also I would write that it is a one solution. Okay? So hopefully that helps you kind of go through the mechanics of what you need to do on the other 3 examples. Now I do want to talk about just 2 misconceptions, and then I'll let you go off and finish up the rest of this assignment. You may come into a situation, I think it is on problem number 2, where you have a similar situation as these linear equations, but we got a troublemaker right here. We got this negative just chilling out front. And a lot of people don't know what to do. They know, well, Mr. Brodeur, this is definitely my slope. So negative 2/3. But people don't know what to do with the negative. Does the negative go to both 2 and 3? Does it just go to 2? Does it just go to 3? Can you choose where it goes? What in the world can you do? Well, how many negatives do you see right here? You only see one negative. So you cannot write it as -2, -3. That is incorrect because I only see one negative. I do not see 2 negatives. And plus, those negatives would cancel and be 2/3, which would be a completely different number. So that's a no-no. What you can do is you can either choose to move the negative on the top and make it -2/3, or you can choose to place the negative on the bottom. What I tend to do is I try to stay consistent, so I tend to just throw the negative on the top just to keep it consistent and do the same thing after one after another. But those are your two choices. So if you have a negative out front, do not keep it like that because you need to deal with rise over run and determine which way your arrow is going to go. So in this case, I would know if I went to go graph this, that this would go down and to the right. Or this one would go up and to the left. And notice they are reverses. So that way, determining which way I need to go, that will help me do the slope. And then also my y-intercept here would be 0, -3. So I could go about graphing that. So I hope that helps clear up any misconceptions you may have if there's a negative just chilling out front and it's not necessarily with a number. The last thing we might need to refresh is right here. You have y equals -3. Now this one's weird because where in the world is the x? Well, remember, you could rewrite this equation as y equals 0x minus 3. Now you're like, wait a minute, Mr. Brodeur, there's no x. How did you make a 0x? Well, we know 0 times anything is just 0. So that's why like this and this is the same equation. It's just usually if anything's times 0, we don't need to write it. But this is going to help us because this means our slope is 0. And if you remember, some of you guys might remember Slope Dude from January. Remember, zero fun is an equation or a graph that looks like it's horizontal. It's a flat line, and that will come in handy in a second. And then your y-intercept is going to be, oops, let me erase that and make it a little bit bigger. Your y-intercept is going to be 0, -3. So I'm going to go down and do 0, -3. But remember, my slope is 0. I don't really have a rise over a run. And what I got to remember is if my slope is 0, it's just going to be a horizontal line, just like that. So if you run into this, hint, hint, wink, wink, on problem 3 on this assignment, and you might have a similar scenario, this may be very helpful when you start to graph your graphs. So, all in all, this is everything you need to know for graphing systems of equations. I hope this really helps kind of break down things. And remember, this is a video, so if you need to pause it, work out a problem, compare it, things like that, feel free to do that. And this is why we're trying to do a video so you can work at your own speed and you can watch it over and over again. But remember, all of your math teachers are here to help. So send us an email. Let us know. We're going to try to help you as much as we can to make sure you grasp this stuff, because especially systems of equations is going to come again in 9th grade. So we want to make sure you're prepared for that. But just let us know. Until next time, Brodeur out. Peace.